Good morning, children. Today, let us start that exercise 1. The exercise 1 is related to the surface area and volume of combination of solids. Take down the first problem. From a solid cylinder of height 2.8 cm and diameter 4.2 meter, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid. From a solid cylinder, a conical cavity is hollowed out. The diameter and the height of the conical cavity and the cylinder are same. The diameter is 4.2 centimeter. So the radius is 2.1 centimeter and the height is 2.8 centimeter. Find out the total surface area of the remaining solid. To find the total surface area of the solid, first we have to find out the slant height. You know the slant height. The slant height is equal to the square root of r square plus h square. The radius is 2.1 whole square and the height is 2.8 whole square. 2.1 whole square is 4.41 and 2.8 whole square is 7.84. So 4.41 plus 7.84 is 12.25. The square root of 12.25 is 3.5. So the slant height of the cone is 3.5 centimeter. Now you got the slant height. Next, find out the TSA of the remaining solid. See, if you add the CSA of the cylinder and CSA of the cone and area of the circular plane, that gives the total surface area of the remaining solid. So TSA of the remaining solid is equal to CSA of the cylinder plus CSA of the cone plus area of the circular plane. CSA of the cylinder, you know, 2 pi RH, 2 pi RH, and CSA of the cone is pi RL, and area of the top circular plane is nothing but area of the circle pi R square. Next, here we can take pi R common factor, pi R, then the remaining terms are 2H plus L plus R. Now substitute 22 by 7 for pi, 22 by 7, and the R is 2.1 into 2 into H is 2.8 and the slant height is 3.5 plus the radius is 2.1. Divide 2.1 by 7, it divides 0.3 times. So 22 into 0.3 is 6.6 into 2 into 2.8 is 5.6 plus 3.5 plus 2.1. 6.6 into 5.6 plus 3.5 plus 2.1 is 11.2. Multiply 6.6 into 11.2, you will get 73.92 square centimeter. So the total surface area of the remaining solid is 73.92 square centimeter. Next question. A hemispherical tank of diameter 3 meter is full of water. It is being emptied by a pipe at the rate of 3.4 by 7 liter per second. How much time will it take to make the tank half empty? Here, the diameter of the hemisphere is 3 meter. D is equal to 3 meter. So the radius is 3 by 2 meter. And the rate of flow of water is 3.4 by 7 liter per second. So the rate of flow of water is in mixed fraction, convert into improper. So 3.4 by 7 is 25 by 7 liter per second. So you know 1 liter is equal to 1000 meter cube. Convert the liter into meter cube. So divide by 1000. 25 by 7 into 1000. So divide 1000 by 25, it divides 40 times. So the rate of flow of water is 1 by 280 meter cube per second. Now let the time taken to empty of the tank be t seconds. Therefore, rate of flow of water into time taken is equal to half of the volume of water in the hemispherical tank. Rate of flow of water is 1 by 280. 1 by 280 into the time is t is equal to half into the volume of the water in the hemispherical tank is nothing but the volume of the hemisphere 2 by 3 pi r cube. Cancel this 2. Next, t by 280 is equal to 1 by 3. Substitute 22 by 7 in place of pi and the r is 3 by 2 into 3 by 2 into 3 by 2. Next, take the cross multiplication. Then t is equal to 280 by 3 into 22 by 7 into 3 by 2 into 3 by 2 into 3 by 2. 7 ones are 7 40s. Cancel this 3. Then 2 ones are 2 11s. 2 ones are 2 20s. Next 2 ones are 2 10s. So t is equal to 990 seconds. So convert 990 seconds into minutes. 990 seconds is equal to 16.5 minutes. Therefore, the time taken to empty the tank is 16.5 minutes. Next problem. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 cm and the total height of the vessel is 13 cm. Find the inner surface area of the vessel. Here, the vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is given 14 cm and the total height of the vessel is 13 cm. So, the height of the cylinder is 13 minus 7, 6 cm. The diameter is 14 cm. So, the radius is 7 cm and the height of the cylinder is 6 cm. Therefore, inner surface area of the vessel is equal to CSA of the hemisphere plus CSA of the cylinder. You know the CSA of the hemisphere, that is 2 pi r square, and CSA of the cylinder is 2 pi r h. Here we can take 2 pi r common factor and the remaining terms are r plus h. Now substitute 22 by 7 in place of pi and the r is 7 cm. Again r is 7 and the h is 6 cm. We can cancel the 7. 2 into 22 is 44 into 7 plus 6 is 13. 14 into 13 is 572 square centimeter. So the inner surface area of the vessel is 572 square centimeter. Next question. A toy is in the form of a cone mounted on a hemisphere of same radius 7 centimeter. If the total height of the toy is 31 centimeter, find its total surface area. Here, the toy is in the form of a cone mounted on a hemisphere. The radius of the hemisphere is given 7 centimeter and the total height of the toy is 31 centimeter. So, the height of the cone is 31 minus 7, 24 centimeter. The radius of the hemisphere is 7 centimeter and the height of the cone is 24 centimeter. So, first find out the slant height of the cone. You know the slant height. L is equal to square root of R square plus H square. R is 7 square and H is 24 square. 7 square is 49. 24 square is 576. 49 plus 576 is 625. The square root of 625 is 25 centimeter. So the slant height of the cone is 25 centimeter. Now you got the slant height. Next, find out the total surface area. If you add the CS of the hemisphere to the CS of the cone, that gives the total surface area of the toy. Therefore, total surface area of the toy is equal to CS of the hemisphere plus CS of the cone. You know the CS of the hemisphere, that is 2 pi r square, and CS of the cone is pi r L. Here we can take pi r common factor. Then the remaining terms are 2r plus L. Substitute 22 by 7 in place of pi, and the radius is 7 centimeter. 2 into 7, the slant height is 25. Cancel the 7. 22 into 2 sevens are 14 plus 25. 22 into 14 plus 25 is 39. Multiply 22 into 39, you will get 858 square centimeter. So the total surface area of the toy is 858 square centimeter. Next question. A hemispherical depression is cut out from one face of a cubical block of side 7 cm such that the diameter of a hemisphere is equal to the edge of the cube. Find the surface area of the remaining solid. Here, a hemispherical depression is cut out from one face of a cubical block such that the diameter of the hemisphere is equal to the edge of the cube. So here the diameter and the edge of the cube is 7 centimeter. If you add the total surface area of the cube and curved surface area of the hemisphere and subtract the area of the circular region, that gives the area of the remaining solid. Let A be the edge of the cube. You know, the edge of the cube and the diameter of the hemisphere are same. So let A is equal to D is equal to 7 centimeter. If the diameter is 7, then the radius is 7 by 2 centimeter. Therefore, area of the remaining solid is equal to TSC of the cube plus CS of the hemisphere minus area of the circle. You know the TSC of the cube, that is 6a square, plus CS of the hemisphere is 2 pi r square, and area of the circle is pi r square. 6a square plus 2 pi r square minus pi r square is pi r square. 6. The edge of the cube is 7 centimeter. 7 into 7 plus substitute 22 by 7 for pi, and the radius is 7 by 2 into 7 by 2. 7 get cancelled. 2 ones are 2 11s are. 6 into 7 into 7 is 294. 294 plus 11 sevens are 77 by 2. 294 plus divide 77 by 2, it divides 38.5 times. Add 294 and 38.5, you will get 332.5 square centimeter. So the area of the remaining solid is 332.5 square centimeter. Next question. A wooden toy was made by scooping out a hemispherical form of same radius from each end of a solid cylinder. If the height of the cylinder is 10 cm and its base is of radius 3.5 cm, find the volume of the wood in the toy. Here, a hemispherical form are scooped out from both the ends of a solid cylinder. If you subtract the volume of the two hemisphere by the volume of the cylinder, that gives the volume of the wood in the toy. Here, the radius of the hemisphere is 3.5 centimeter. R is equal to 3.5. We can write 3.5 as 7 by 2 centimeter, and the height of the toy is 10 centimeter. Find out the volume of the toy. Therefore, the volume of the wood in the toy is equal to volume of the cylinder minus volume of the two hemisphere. So, the volume of the cylinder is pi r square h minus volume of the hemisphere is 2 into 2 by 3 pi r cube. Here we can take pi r square common factor, pi r square, then the terms remaining are h minus 4 by 3 r. Substitute 22 by 7 in place of pi, and the radius is 7 by 2 into 7 by 2 into the h is 10 minus 4 by 3 into the radius is 7 by 2. We can cancel the 7. 2 ones are 2 11s. 11 into 7 is 77 by 2 into 10 minus 2 ones are 2 2s are 7 2s are 14 by 3. 77 by 2 into 10 3s are 30. 30 minus 14 is 16 by 3. 2 ones are 2, 8s are 16. So multiply 77 into 8 is equal to 616. Divide 616 by 3. It divides 205.33 times. Therefore, the volume of the wood in the toy is 205.33 centimeter cube. Next question. A tent is in the shape of a cylinder surmounted by a conical top of same diameter. If the height and diameter of the cylindrical part are 2.1 meter and 3 meter respectively, and the slant height of the conical part is 2.8 meter, find the cost of canvas needed to make the tent if the canvas is available at the rate of 500 rupees per square meter. Here, the tent is in the shape of a cylinder surmounted by a cone. Here, the diameter of the cylinder and the cone are same. To find the area of the canvas required, we have to add the curved surface area of the cylinder and curved surface area of the cone. The diameter is 3 meter. So, the radius is 3 by 2 meter, and the height is 2.1 meter, and the slant height is 2.8 meter. Therefore, area of the tent is equal to CSA of the cylinder plus CSA of the cone. So, you know the CSA of the cylinder 2 pi r h, and CSA of the cone is pi r l. Take pi r common factor, then remaining terms 2h plus l. Substitute 22 by 7 in place of pi, and r is 3 by 2 into 2 into h is 2.1, and the slant height is 2.8. 2 ones are 2 11s. 11 into 3 is 33 by 7 into 2 into 2.1 is 4.2 plus 2.8. 333 by 7 into 4.2 plus 2.8 is 7. Cancel the 7. So 33 square meter. So the area of the tent is 33 square meter. Therefore, the cost of canvas needed is equal to area into rate. Area is 33 square meter and the rate is 500 rupees per square meter. 33 into 500 is 16,500 rupees. So, the cost of the canvas needed is 16,500 rupees. Next question. From a cuboidal solid metallic block of dimensions 15 cm into 10 cm into 5 cm, a cylindrical hole of diameter 7 cm is drilled out. Find the surface area of the remaining block. In the figure, a cylindrical hole is drilled in a cuboidal block. So, to find the surface area of the remaining block, add the TSA of the cuboid and CSA of the cylinder and then subtract area of the two circles. Here, the length of the cuboid is 15 cm, breadth is 10 cm, let the height of the cuboid be capital H. So, the height of the cuboid is 5 cm. In the cylindrical hole, the diameter is 7 cm. So, the radius is 7 by 2 cm and the height of the cylindrical hole is 5 cm. Therefore, surface area of the remaining block is equal to TSA of cuboid plus CSA of cylinder minus 2 area of circles. TSA of cuboid, 2 into LB plus BH plus HL plus CSA of the cylinder is 2 pi RH minus area of the circle is pi r square. 2 into L is 15 cm, 15 into 10 plus BH is 10 into 5 plus HL is 5 into 15 plus 2 pi is 22 by 7, R is 7 by 2 and H is 5 minus 2 into 22 by 7, then the radius is 7 by 2. 7 by 2 into 7 by 2. We can cancel the 7 and this 2. Here cancel the 7. This 2 ones are 2 11s are. Next 2 into 15 tens are 150 plus 50 plus 75 plus 22 into 5 is 110 minus 11 into 7 is 77. 2 into 275 plus 110 minus 77 is 33. 2 into 275 is 550 plus 33. 550 plus 33 is 583 square centimeter. So, the surface area of the remaining block is 583 square centimeter. Next question. The rainwater from a 22 meter into 20 meter roof drains into a cylindrical vessel of diameter 2 meter and height 3.5 meter. If the rainwater collected from the roof fills 4 by 5th of the cylindrical vessel, then find the rainfall in centimeter. Here, the length and breadth of the roof is given. We have to find the height of the rainfall. Length of the roof is 22 meter, breadth is 20 meter and the height of the rainfall H we have to find out. And the diameter of the cylindrical vessel is 2 meter, so the radius is 1 meter and the height of the vessel is 3.5 meter. So write 3.5 as 7 by 2 meter. Therefore, rainwater collected from the roof is equal to 4/5 of the volume of the cylindrical vessel. So the rainwater collected in the roof is nothing but the cuboid. So the volume of the cuboid is L into B into H. 4 by 5. The volume of the cylindrical vessel is pi r square H. So L is 22. The breadth is 20. H we have to find out 4 by 5 into pi value is 22 by 7. Then radius is 1 square and the H is 7 by 2. Next, take the cross multiplication. Therefore, H is equal to 4 by 5 into 22 by 7 into 7 by 2 into 1 by 22 into 1 by 20. Cancel this 22 and this 7. 2 ones are 2, 2s are 4, 2 ones are 2, 10s are. So H is equal to 1 by 50. It is in meter. Convert the meter into centimeter. So 100 by 50 centimeter. 51s are 52s are. Therefore H is equal to 2 centimeter. Therefore the height of the rainfall is 2 centimeter. Next question. A sphere of diameter 12 centimeter is dropped in a cylindrical vessel partly filled with water. If the sphere is completely submerged in water, the water level in the vessel rises by 3 pi by 9 centimeter. Find the diameter of the cylindrical vessel. When a sphere is dropped in a vessel partly filled with water, the level of the water rises to a certain height. Let the height of the water rise to be small h. The diameter of the sphere is 12 centimeter, so the radius is 6 centimeter. And the height of the water raised in the vessel is 3 pi by 9 centimeter, so that is equal to 32 by 9 centimeter. We have to find the radius of the cylindrical vessel. Therefore, volume of the sphere is equal to volume of the water raised in the vessel. Volume of the sphere is 4 by 3 pi r cube. Volume of the water raised in the vessel is nothing but the volume of the cylinder, pi r square h. We can cancel this pi. 4 by 3. The radius of the sphere is 6 centimeter. 6 into 6 into 6 is equal to r square. The radius of the cylinder we have to find out, right as it is, and the h is 32 by 9. Next, take the cross multiplication. Therefore, r square is equal to 4 by 3 into 6 into 6 into 6 into 9 by 32. 4 ones are 4 8s are 32. 3 ones are 3 3s are 2 4s are 2 3s are 2 2s are 2 3s are 2 1s are 2 3s are. So r square is equal to 81. So r is equal to square root of 81. The square root of 81 is 9 centimeter. The radius of the cylindrical vessel is 9 centimeter. Then diameter is equal to 2r. 2 into 9, 18 centimeter. Therefore, the diameter of the cylindrical vessel is 18 centimeter.